Okay, in this video I want to discuss with you and describe how to create card guides in Alibre sheet metal. Now, to bring everyone up to speed on what a card guide is, it's a stamped metal sheet metal feature in it's in a sheet metal enclosure that will be used to guide and hold circuit boards in a framework so they can be plugged in and inserted into the back plane where all the power and distribution of signals and everything comes off of. So in this case here, there's a room for several circuit boards that can be slid in here, and they're guided in top and bottom and then held in place. So to begin with, sheet metal features like this have to begin their life as a solid model part. So let me just go through the steps and how I created this one, and I'll just roll this back to the beginning. So I start out with a base, so I have to have something to build on, and then I created these tabs that come up the side so that I can, at some point, I'm going to be using the surfaces on these features to build my build the card guide on. So I have this shape extruded on here, and look at the sketch. What I have here, I've got named parameters in here for the different dimensions that are going to be changed. So this is the profile on each side. It's mirrored about the middle on the central axis. And then I've got this radius on here because this is going to come out to the ends, and then there'll be a draft on the ends that will help to define the compound curve on the end of the sheet metal or the form of the guide. So we have a gap, which is in some cases you're going to have this gap at the bottom defined for different thicknesses of cards. You're going to have an angle that's going to be defined. Some of them are at 0, some of them are up to 20 degrees. Sometimes they're just, that's a total width, so our total angle. And then the height. Some of them are taller, some of them are shorter. So once I have the sides defined, they're extruded out to the almost all the way to the end. I've got them coming out so that they're offset from the end by 30 thousandths. And I've got that linked to the length of the base so that I always end up with a short tab on the end here. And you'll see the reason for that coming up. The next thing I did is I put draft angle on the end face. So on both ends they're drafted in, and right now that draft angle is set to 45 degrees. And then I applied a radius on the ends here. So this will eventually be the lead-in radius on the on the ends of the card guide. So you can already see that this radius on the fillet on this edge here and this fillet here, they're starting to define this edge here, which is going to be the compound curve of the form of the card guide. And then we have a fillet on the bottom, because when you're forming material, you're always going to have a radius on the inside, the bend radius, and then that gets defined as an outside bend radius as you thicken it. So the next step is to delete surfaces, or delete the faces. And here's where I picked all the faces that are not going to be used or needed in the for the creation of the card guide. So basically just the stuff on the inside here is where I'm gonna use that as the guide. Let me hide the surface again. So then we end up with this card guide, which has the radius lead-in angle, and as you can see, the thickness kind of has a nice nice compound curve as it sweeps around from this flat here all the way up to the top. Now I have parameters in here that will be adjusted so that you can come up with whatever size requirements you have on your for your card guide if you're so inclined to use this tool. And I've created a PDF of a drawing to show the parameters that need to be changed and what they're controlled by, or which parameters control what. So we're going to have the overall length at ZZ0. We're going to have a guide height, which is ZZ1. ZZ2 is going to be our gap at the bottom. Going to have our angle, and then we're going to have material thickness. And that's so that you can match it up to the material that you're putting this into, whether it's going to be 16, 18, 14 gauge. This part, I should note, has been tested. I've tested this through various heights and material gauges. I've tested it for 18 gauge, 16 gauge, and 14 gauge. I don't know that it's going to be used in anything heavier than 14 gauge. That would be a lot of stress on the tooling to make a 14 gauge tool like this, I think. But at any rate, how this gets used, let me bring up a sheet metal part. So we start out with a sheet metal part. Again, you punch your hole through this so that it fits your, the length is going to be the same length as your card guide part. And we're going to use the Boolean features again. So we go to Boolean Unite and grab the card guide. Let me so this, we'll bring this in, and then with some constraints we're going to grab the top face of that and the top surface of the sheet and apply that, and then we'll mate these end faces. And it'd be helpful too to turn on reference geometry in this case. So now we're going to grab the central plane and this, and we'll do an offset here, 0.25, and we'll reverse that. Okay, now I made my cutout here a 1/2 inch wide. So I know that going midway there's going to be a 1/4 inch there. And then before you accept, go ahead and turn your reference geometry off again, and then commit the Boolean. And there you have your stamped card guide in this particular piece here. Now this is a piece of or sheet is 18 gauge. Now it might be beneficial to in your part to create a configurations in your card guide. So to demonstrate that, what I have is I have a configured card guide here. So let me bring this in and place it. And if you expand this up here, you'll notice that I've got two configs in here. And right now it's set at 16 gauge and 250 long. So obviously that's not going to fit in this cutout. Let me get it aligned up here. So if we activate the 18 gauge config, and then we can go ahead and constrain it in place. Let me change this one here, get this one constrained. There we go. And again, show a reference geometry, and then offset that to 0.25. And commit. Okay, so that's basically the use on that. Again, if you need to pattern these, it's easy enough to pattern. Just make your cutout large enough to carry the array of guides that you're going to have in here, and then just make sure that your pattern is inside the Boolean. As far as the size of your cutout, that's going to be determined by the tool that you're using, and it's probably beneficial to talk to your tooling supplier to find out what kind of clearances you need around that tool for their punch to create this feature. So what I'll do is I'll put this piece out on in the resources along with this drawing. I'll have these in a zip folder for you, and so again, I hope this is a beneficial tool for somebody out there, and enjoy. Talk to you later.